Right folks, the question that we're faced with here today is based off the topic of surface geometry, and it is another transition piece. So we can see the pictorial view here, 3D graphic here, another pictorial view, the elevation, the plan. But starting off, I'm just going to read the question and see what it's asking us to do. So it says, the graphic of a hover nozzle is shown, the projections of a similar nozzle are given, and complete a one-piece surface development of half the transition piece between the square top and circular base. And it says the seam should start at point O. So we can see, obviously, we've got, as I said, pictorial view here, we've got the elevation up here, the plan down here. Now, it's saying when we're doing the transition piece, and what it means by transition is, it's saying we've obviously got a square top, and it's transitioning down onto a circular pattern here. And you can see, obviously, up here, square top, it's flat, so it is, and it's obviously coming down here and it's joining up with this circular bit here. So it's going from a square to a circle, essentially. And what we have to do is we have to do the one-piece surface development of that. Now, in this instance, they're not asking us for the full surface development of this section up here. They're not asking us for this bit down here. They're just getting this bit, but they only actually want half of it, starting at O. So essentially, if we do half of it, we're going to be doing from here all the way around to roughly here. That'll give me half of it. And once I've half of it done, obviously I don't have to do the other half. Okay, so the way we have done these questions previously, anytime we're doing a surface development question on a transition piece, is we use the triangulation method. And eventually then what we do is we work out the various true lengths, and with those true lengths then we work out the true shapes and we complete it up to the point that we have to. Okay, so when we are actually doing that, well, first of all we start off with a couple of labels. So this square piece at the top, I'm going to label it straight away with letters. So I'm going to call that corner A, this is corner B, up here is C, and up here is D. So of label and plan, label and elevation, so A is at the front, D is at the back, but for the sake of it now I'm just going to put the both from there, and then we got B and C over here. B is at the front, C is at the back. Okay, now if I label the top of it, I also need to label the bottom of it, and the bottom of it here we can see is circular. So anytime you have a circular section, you're going to split it up into, like a clock, 30, 60, 12 pieces. So split that up, 30, 60. Now that we have that actually broken up into 12 pieces in our plan, I'm going to now label it as well, and this time with numbers. So at this point here is 1, 2, and so on. Okay, if I label it in plan, I also have to label it in elevation. So 1 and 7 were just up here, so there's 1 up there, 7 will join all the way up here, and so on. So 6 and 8 up there, 5 and 9, 4 and 10, and 2 and 12. Okay. Now at this point, just to explain, I'm not going to label it all the way around as far as 12. I'm actually just going to focus on the side from 1 all the way around to 7. And the reason for that is, I put it all in the whole way along, but the reason for that is because I actually don't need to, it says I only need to do half the transition piece, so I only need to do as far as 7. So I'm going to label it from 1 to 7 as well. So 1, at this point 2, 3, 4, 5, 6, and 7. And obviously where 6 is 8, 9, 10, 11, 12. Okay. Now at this point, when we are doing a transition piece, we always use the triangulation method, and we split it up into our various triangles to be able to complete it. And to do that, what I'm actually going to have to do is join all these top points to the main points on the clock. When we think of the points on the clock, if you imagine, I know this is labelled 1, but if we imagine where 12, 3, 6 and 9 would be, and they're the main points. So at A, I would join that to 3, or technically 1 here now, and it would be the same for D. I'll just do it for D now. Okay, even though I know I'm not using this half of it, I'm just going to put it in for explanation purposes. Now, where A joins to 1, it also joins to number 4. Okay, and then B. B will join to 4, and it would also join to 7. Okay, now at this point usually I would have D joining to whatever it is here 1, D would also join to 10, C would join to 10, and C would join to 7. But I'm not going to put them in. I just put in this one because I'm going to show you on my little graphic over here how that actually goes together. So if I was to label the graphic over here, I've got A, B, C, D. So this corner here is A, this one is B, C, and D. And then if I was to label it 1 around to 7 or 1 around to 4, however we'd see it, I might have a point here. We'll call that one 1, 2, 3, and 4. Okay. Now, as I said, A joined to 1. So I'll join that down to 1. And A also joined to 4. Okay, now in this case B joins to 4 and B joined to 7. Now you can't see 7, it's over here at the back somewhere if I was to put it in, but I will join it to 4. And you can see our D also joined to 1, so I put D in as well. Okay, now you can actually see in this little graphic here what we have is a series of triangles. Okay, we've got a triangle here, and then this one here, and that's the one there where this part is starting to curve. So we can see A clearly is going to have to join to 3 and 2. Okay, and so I'll just put that in there very quickly. And obviously B would join to 5 and 6 before it goes to 7 as well, and D would join to whatever respective numbers that is. Now it's in this section here, it's very important to understand. In this section here and this one, they are flat surfaces, so they're actually flat, they're not curving surfaces. It's actually in the section from 1 to 2, 2 to 3, 3 to 4, inside in here is where it's actually starting to curve. And like I did the previous day, if you can imagine, it kind of is starting to curve upwards as it goes towards the top. So I'll just put that in as best I can. And it's starting to curve in there like that. And obviously over here, once again, it is also curving on the way up. And what we have to do is we have to basically get the true lengths of all of these lines here. Okay? Now, if I've explained it there in the graphic, I'm also going to put it in here in my plan view. So as I said, it's joined to 1, it's also got to join to 2, and it's also got to join to 3. So that's A to 1, A to 2, A to 3, A to 4, which if I had it done over here would have been the same as D to 1, D to 12, D to 11, D to 10. But we don't need to do that because we're only doing half it. Now B has joined to 4, it also has to join to 5, it's already joined to 5 luckily enough, and it also has to join to 6. Okay? Now, at this point then, we're going to have to work out the various true lengths that we have of all of these. But if I have it done in plan, I should also do it in elevation. Now A joins to 1, A also joins to 2, it joins to 3, and it joins to 4. Now B joins to 4, to 5, to 6, and as you can see already, it has been joined to 7 already. Okay, and you can actually see, if you look up here at this triangle, that triangle there, which is on the outside, is the same as the one that I basically put in here and I represented over here. And we're going to have to get the true shapes of all of them. Now, before we get the true shapes, we have to work out our various true lengths. And to be able to work out our true lengths, we're just going to use the cones principle that we have previously done. So I'm going to take A as the apex of a cone, and I want to work out the true length from A to 1, and then A to 2, A to 3, and A to 4. So if I take A as the apex of a cone, okay, alright, and I want to work out the true length from A to 1. So we know when we look down on top of A, because it's the apex of a cone, the center of a cone when we look down on top of it would actually represent a circle, and the radius would be from A to 1. So we're going to take that distance on our compass from A to 1, right there like that, and it's a case of then stepping it out. Now, do I step it out from here on the XY line? No. The reason for that is because 1 isn't on the XY line, 1 is actually up here. So it's very important to recognize that 1 is actually up here. So we'll step that out. Not sure exactly how far I'm going to need. So as I said, took that distance on my compass and going to step it out for 1. Now as you can see, I need to go out a little bit further. And there's 1. That is the true length from A to 1. So I'll just call that A to 1. There we go. Okay. The exact same now for A to 2, A to 3 and A to 4. So get the compass distance from A to 2. A little bit shorter. There it is. Have that ready. And then from where 2 is up here, it's not along the same line as 1 because 2 is at a different height. So that does make a difference. You can see it's a bit shorter. So I'm just going to give it a little bit shorter on the line. And from this point here, mark it. And here we go. And it's actually coming out almost on the line. Actually coming out at the same distance, or the same. It's coming out on the exact same line, only it's going to be a shorter distance. So I'm just going to put in a little arrow there, and I'm going to say A to 2 is that distance, whereas A to 1 was this distance here. Okay, so that's my 2. I have to do the same for A to 3. So I'll mark A to 3 there. Somewhere out along that line is going to be A to 3, and the same with A to 4. Don't know exactly yet, but I'll just mark them off. So take the distance from A to 3, and A to 3 is this one here. It's going to be out a little bit further actually, and then I'll do the A to 4, and that one's going to actually go further as well. There we go. So my A to 3 was all the way out here. And my A to 4 is all the way out there. So I'll call that one the 4. That's the 3. Join them both back to A. And this one as well. And there we go. So that one is the A to 4, and this one is the A to 3, and A to 2 and A to 1 are actually on the same line, only A to 2 is slightly shorter. Okay, now I've worked out all the true lengths from A to 1, 2, 3 and 4. Now I'm going to work out all the ones from B to 4, B to 5, B to 6 and B to 7. So with that in mind, I'm going to do it, if I've done A on this side, I'm going to do the B one over here on this side. So you know the sequence now. So at 4, taking B as the apex of a cone. So at 4, this time I'm going to step out 4 this way. 3 will be the same. Don't know exactly where they're going to be needed yet. I'll probably take my lines maybe a bit far. But that's going to be on my 4 line. That's going to be on my 5, my 6 and my 7. And once again, take the radiuses from my plan. So from B, I'm going to mark B to 4. You can see these are actually a good bit smaller now. So there's B to 4. And on the, sorry, I should have. I was doing it exactly after 4. What I'll actually do is I will bring my B out. And instead of having B here, starting at this point, I'm going to extend it out. There we go. So if you imagine we just brought B across, B is now here. And what I have to do now is just take the radiuses. So B to 4, as I said, that distance there. Wherever the 4 one was, which was the bottom one, there's the 4. Now I'll take the 3, or the 5 I should say, sorry. There's the 5, come up to the 5 line at this point then, right there. There's the 5. Do the same for 6 and same for 7. and 6, which is on this line. And then the exact same for 7, which is going to be the longest one. That distance there, and at the 7 one, mark it out, just had enough. And there's the 7. Every one of them should join back now to B, and they will all be my true lengths. So I've got B to 4, B to 5, B to 6, B to 7. So B to 7, B to 6, B to 5, B to 4. Okay, now at this point I have all the true lengths of the various triangulation lines got, and usually when we have a circle in our plan view, we can usually take them, the distance between 1 and 2, 2 to 3, 3 to 4 and so on, because they're all the same, as the true lengths. And obviously we just mark them off on our compass from 1 to 2, which is the same as 2 to 3. The problem is, this circle here in plan is not the true shape of the actual circle that it's joining onto. And the reason for that is because if we look at the circle in elevation, we can see that it's actually not parallel or sitting on the XY line. It's actually at an angle to the XY line, so it is. And what we have to do is we have to get the true kind of shape of that circle now. So to get the true shape of that circle, and we only need half of it, so we do. So to get the true shape of that circle, I'm going to take out half of it straight away. So I know my 4, I only need the 1 to 7. So I know my 4 is out here somewhere. I'm just going to project it out. I know my 5 is going to be out here. I'm sorry, my 3 and my 5. My 2 and my 6. And my 1 and my 7. Okay. Now, if I was to put in an axis in the middle, an axis is usually long line, short line, long line. Okay, axis in the middle. Let's make it a little bit heavier so that you see it there. There's my axis. Now it's a case of working out exactly where the points are. And what we need to do is basically work out where the 1, 2, 3, 4 and so on is. Now, the 4 is going to be right in here in the middle. That point is there as it's going to start off. And now what we have to work out is the distance from 4 to 3 going this way, and then 4 to 5 going that way. Obviously we're not going to take it from the plan, because that's where we're after projecting from, but we're going to take it from the elevation. So a little bit of sliding set squares here. Now what I have to do is I have to look perpendicular to that edge right there. And to be able to do that, I'm literally just going to set up my 45 degrees on it, and then put my 30-60 behind it, and then literally just rotate it. So 45 on it, parallel with the edge, and literally rotate around. And that gives me, as you can see here, 90 degrees perpendicular. So at the 7, 6, this is literally all just to work out distances. You don't have to take it this way, I'm just illustrating it. I'll explain why in a second. Okay, and I'm actually going to put that in a different colour. Now, there to there. Okay, use a different colour once again. And finally, one last different colour. Okay, now the reason I just brought out those lines is just for a bit of understanding. You didn't actually need to do it, it's just to help us understand it and where the actual distances we're going to take are coming from. So, just looking here, as I said, 4 was on our axis. That is the main point starting out. what I don't know is, because we couldn't take this distance from here to here, from 4 to 3 there as a true length, or the true width of it from there to there, okay, the actual true width of it is this distance from here to here, or there to there. 4 to 5 is the same as 4 to 3. So I'm actually taking it from my elevation, so I am. And what I have to do is just take that distance on my compass. And we can see that 3 to 4 was the same as 4 to 5. 2 to 4, which is in the axis, is the same as 4 to 6. And then 1 to 4 is the same as 4 to 7. So when I work out from the middle, I'll just do it here. So I'll take the 4 and the 7 first, which is the same as 4 and 1. Take that distance there. And wherever 7 and 1 are, which is here and here, I'm going to go into my middle, and literally that's going to be my 7, that's going to be my 1, and straight away just label them. There's my 7, there's my 1. Okay, now I have to do the distance from, so I've done 1 and 7, now I'm going to do 2 and 6. So I'm going to take the distance from the middle out to my 2, this distance this time, and then go to the 2 and 6 line. There's the 6, there's the 2. 2. And the last one we obviously have is the 3 and the 5. So take that distance from 3 to 5, or 3 to 4, which is the same as 4 to 5. And then from the middle, just mark it out. There's my 5, and on the opposite side, there is my 6, or sorry, 3. 3, 5. And what we do then is, now that we have all the points, literally just freehand the curve. Because essentially what we're doing here is we're almost drawing the true shape of that curve. I shouldn't say almost, we are. Just heavy that in. I'm obviously not putting in the full one because we're only developing out half of it. There we go. A little bit tricky, but right there now, what I'm actually going to do moving forward when we're doing the surface development of it is, I didn't take the distance from 1 to 2, which was there on this portion, but now I can take the distance from 1 to 2, which is here, and you can actually see it's a tiny touch bigger, but that is very important because that is in fact the real true length on the curve, from there to there, not from here to here. Very, very important. Okay. Now at this point what I'm actually going to start doing is developing out the question. Okay, and just going to move over here a slight bit. Okay, you can see it there. And I'm going to pick a start point. And as they said, our start point we're developing out from the midway point, which is on 0, right here. So I'm going to go from 0 to A because we're developing out half of it from here. Okay, so with that in mind, I'm actually just going to put in a line down here. I'm going to put in this, I'll use a green, because we're doing half of it. So what we're actually doing here is, we're going from 0 down to 1, and then 1 up to A. We're getting that portion of it there, which is essentially, if I came over to my 3D graphic here, that was my 0. 0 was joining down to 1. Like this. And what we're doing first of all is this bit here. Then we'll work on to this bit, this bit, this bit, and all the way around. Okay, so if I start with 0, I'm going to just pick a point starting off, and yeah, I'll pick about here. There's my 0. So straight away I need to get the true length from 0 to A, and I can take that straight off the sheet. 0 to A. Right there. Take that distance off the sheet, and that's 0. Mark down. And somewhere along that arc is going to be my A. It's directly below it. So just using my T-square. And there's A. straight away, true length got. Now, once again, we have to make, as I said, that triangle 0, A, 1, because we're only doing half it. Usually when we were doing the full transition piece, we were doing from A to D to 1. But this time we're only taking half of it. Okay? So now I'm going to take the true length from A to 1, and then I have to work out the true length from O to 1. But A to 1, do I have it worked out already? Yes, I do. I did it up here. And my A to 1 was the longest one here, which was that distance right there. And I have my A, which is here. Oh, it's going very close to it. Somewhere along that arc there is going to be my 1. Now I need to work out the true length from O to 1. Now, I didn't work it out yet, but do I have it on my sheet already? Yes, I do. Because my O is in the same position as AD. So technically AD, O is at this point here. So, and my 1 is down here. So we can see the line O1 is there. And the reason that line there, O1, that one there, is actually the true length already, and it's already worked out, is because my O1 in plan is parallel with the XY line. And any line that is parallel with one of the principal planes in one view, it means it's a true length in the other. So because it's parallel in plan with the principal plane, with the XY line, that means that it is a true length in my elevation. So I can just take that straight from the elevation there, O1. There we go. Take that distance from O to 1. And at O, mark it. Okay. And right there, I have my 1. Now, join that up. That's the first part of the triangle done. There we go. So there's half of it, obviously. Okay, which is this. I basically got the true shape from O to A to 1. O to A to 1. That's the true shape of it there. Now I have to work out A1, 2. Okay, and let's work out A1, 2, and let's just see what it looks like. Okay, so do I have the true length from A to 1 done? Yes. Do I have the true length from A to 2? Yes. Do I have the true length from 1 to 2? Yes. It's not here, but if you remember, we worked it out over here. So 1 to 2, I can take that straight off the sheet, right there like that. Oh, make sure I take it correctly. Right there, that's the distance. And at point 1, going to do an arc. And somewhere along that arc is going to be my 2. Now I have to get the true length from 1 to 2, or sorry, A to 2. And my A to 2 was along the same line as O to 1, the way I worked it out a while ago. It's just a little bit shorter. So it's that distance right there. And at A, mark it off, or crossover. That's my 2. You can see it's kind of going into other parts that I've done. Now the same thing from 2 to 3, and we keep going in this sequence. So 2 to 3, take from over here, and at 2, mark it off. Somewhere along that arc is 3. Take the true length from A to 3. So A to 3 was this one. Let's take that distance there. And at A, mark it off until it cuts the 3. And there we go. There's my 3. And then the same from 3 to 4. Right there. At 3. Somewhere along that arc is going to be my 4. And then take the true length from A to 4. So got it here. At A. And as you can see with my 3, just get that distance again. There we go. And at this point there is going to be my 4. Now, every one of them should join back to A. And also at this point, this is curving here. So I'll start to put it in lightly. There we go. So now at this point, I would actually take them off just to know what I've done. So I've done that one, done this one, done this one, done this one. Now what we actually have to work out is the next portion. And the next portion is A, B, 4. Just, it can get a little bit confusing with the lines here because I know they're overlapping each other, but it's actually A to B to 4. Okay, because we've got A4 and we have to find B. Okay, so take the true length from A to B, which I can take directly in my plan, or my elevation technically. AB, somewhere down here is going to be my B, and now I need the true length from B to 4, and I have that over here. I got that earlier. So it's this one, the very first one, right there, and at 4, we're trying to find B. There we go. There's our B. And once again, join them up. Okay, now we're on to this section here. We've done B to 4, now we have to get to B to 5, 4 to 5. So just keep going in the same sequence. 4 to 5, and at 4, make a mark, make an arc I should say, and then we take the true length from B to 5. And at B, right across, there's 5. Do the same, find 6 and 7. Take the true length from B to 6. And there's 6. And finally, the last one from B to 7. So I take the true length from 6 to 7. And then work out B to 7. Okay. There's my 7. And the very, very last one, join them all back up. And that actually is the full surface development of the transition piece. Well, I should say, half of it. Not the full one. Okay, there we go, and just once again tick, 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 tick. Okay, all of it done there now. Quite a tricky question in the sense that it was a very irregular shape, but if you can kind of visualize it and work your way around it, these questions aren't actually that bad. It's just a case of working out, like some people might have made a mistake up here when they were working out the true lengths and actually taking it from here on the XY line, whereas it's not. You have to take it from where the height of the points are. In other questions we've previously done, where the circle was on the ground or at the top, they were on a flat plane, whereas you can see here 1 all the way up to 7 was only where they were rising. So 1 was taken from this height, 2 this height, 3 was this height, 4 this height, 5 over here, and so on. Okay, so that's very important to recognize how we got the true lengths up here, and then also recognizing that these distances inside in here aren't actually, they weren't the true lengths of those arcs that as we could accurately take them. They were actually the distances out that I took here. So that blue one there, if I just put it in over here for explanation purposes, is this one. That's that distance there. The exact same with the green, which would have been from 2 to 6. So that distance from there to there was this one. And then obviously the last one from 3 to 5 was this one. Now, as you can imagine, I didn't obviously have to project out here perpendicular. I was just doing that for understanding purposes so that you could see the distances. Okay, it was very important, alright? Now, I hope again you found that question helpful. A lot of little tricky bits in that, but that is the surface development of half the transition piece here. Oh, I actually just realized there, I did actually make one tiny error in the fact that I didn't actually complete the full half surface development. That was actually my apologies there. So I'm just going to fix one line there now. Just realised that they're right at the end. My line from 7 to B, even though you can see I heavied it in right here, just to take you back, B, the line here was joined to 7, and half the piece, which when we started was this 0, 1A starting here, going all the way around, working its way around, and I stopped at 7 to B. When there's actually another triangle here, you can actually see it, 7 to B, to this point here. And now that point there, I know it says 1 underneath, but 1 is actually on the circle, but that point there is an actual point as well, and it's very important that we actually find that as well. Okay, so it's just one little point that we're missing there, and it's the true length from 7 up to this, because remember we have 7 to B, it's the true length from here up to here. And in plan, I cannot take that. It was like this green one here, if you remember when I took that one from 0 to 1, which was this distance here, that was the true length from there to there. And it's the exact same thing, it's the true length from here, this point here, down to 7, which is actually here, that distance there. So I need to take that. So once I take that on my compass, which is that distance there, and I am going to step that off of, I have B already got, I'm going to step that from 7. And somewhere down there along that arc is that point. It hasn't been given a label right now. And the other one I have to take the true length from is from, and the other one that joins that, so I've done this one, now I have to join B to it. And I can take the true length from B to that position, to that point there. And at B, I will mark it off, and there it is. So that was actually where it should have finished. I had it done where it was done there, whereas this was the exact actual half of it. So I'll join that up, I'll have it in then, and I will fix my mistake. So I have just a bit of toothpicks here. There we go. I'll put that one back in as a construction line. And then heavy in the final one. And this is exactly what I should have heavied in to finish it off. So, slight error there, just in the sense that I actually forgot to finish off one of my triangles. Apologies about that, but once again, hope you found that helpful. That's the question complete there.